Hello, this is Alex Eames from Raspberry.tv.
I'm here with Pete Lomas from the Raspberry Pi Foundation. Pete runs a company called Norcott Electronics, and he is the person who laid out the original Raspberry Pi board for the original Model B and A, and he's also one of the founding trustees of the Raspberry Pi Foundation, and we had a chance to have a little bit of a chat. So Pete, tell us a little bit about how it all happened.
Yeah, well, so I was at Imperial College with my company, Norcott. We built some boards from Imperial, and they said, well, why don't you come down and actually see these absolutely humongous FPGA boards actually doing their stuff and actually working. We're having like a show and tell day, and at that show and tell day, there was Alan Mycroft, who was a professor of computer science here at Cambridge. And just somehow, I don't quite know how it happened, we were walking over Hyde Park and we got chatting about undergraduate recruitment and how it was dropping off at Cambridge. And I said, well, yeah, we have the same, we're having a bit of the same problem when we're trying to recruit engineers. We're finding that their debug skills with microprocessors has diminished massively, and we don't really know why. He said, oh, we know why, we've been looking at this in some detail. And it's to do with the absence of the sort of modern equivalent of what we used to, the Spectrums, the BBC Micro, and all the other homebrewed computers that you saw, because you had to actually get involved and actually work out what was wrong, why it didn't work, and you had to fix it. And you were literally on your own. There was no internet, and you couldn't Google the answer. You had friends in the club that you might be able to help you, and this had all disappeared. And he said, there's a guy called Eben Upton, who's been thinking about this for a number of years, but for one reason or another, it was like 2006, and then he has sort of put it down, but we're thinking about trying to pick it up again. Would you be interested? So I went down to Cambridge, and within just a few minutes of being in the room with these guys, the enthusiasm was palpable that something needed to be done. And so I just said, well, look, it's fine. Well, what I do for my day job is design electronics from a fag packet and turn it into a bright, shiny production item for people. We can do this for whatever we're going to call this gizmo. And it was just a little bit ahead of John Krokoff calling it a Raspberry. And of course, Pi came from Python, but very quickly it became known as the Raspberry Pi. But, it took a while. We were looking around for a decent piece of silicon. We tried to do it with a 2727.
That's a Broadcom chip?
That's a Broadcom chip. The thing that attracted us to it is it had the VPU. I mean, what we needed something to think about. The kids are playing with computer games. So you've got to have something that's got a reasonable amount of power and has got this graphic capability. I mean, it was no good having something that was like a 320, 240 display, like Eben's original. Now, the game had moved on. Yeah. But we looked at this and we did some schematics and we did some trial layouts. There were some problems with the actual physical device, with it being a 0.4mm BGA. That made the PCB expensive, not impossible but expensive. But it needed a lot of peripheral things and it didn't really quite gel. So we were a bit disheartened. But little did we know that somewhere in the depths of Broadcom, an ARM processor happened to be on the side of the 2835. And then that was almost nirvana. And the big thing was, of course, the original was only intended to run like a desktop Python. That's all it did. But then the possibility of actually running Linux on it,
a full operating system,
and the scope was just immense. And I think from that day when we realised that that was a possibility, we now had a really good target to go for. So from there, Broadcom already had big reference designs, and a guy called Gert van Leeuwen at Broadcom did a sterling bit of work to sort of reduce that to something Pi-esque, if I like to say that, but it had a lot more functionality than we could really afford, because we'd already said that we wanted to produce it at the $35 mark where it'd be cheap enough to break. So if you did actually toast your board, then it wasn't, the end of the world. I mean, we're not encouraging people to go and kill them. What we do want to do is we don't want to hold them back from actually having a go, because that's the critical thing about it. You just have a go. Don't see what
scared of it. Yeah.
No, but I mean, if it was your iMac or something, then you're not going to start tinkering away and soldering bits onto that.
No way.
So that was really the moment where I said, right, so this is where we need to go. So the challenge now is to take this, what was then the Alpha board, which was great because it allowed the programmers to get involved and start hacking around with kernel stuff and try and get the operating system together, because that's a big parallel activity with actually trying to get the hardware together. So we then looked at this and we said, right, okay, let's have a list of features, and now let's go through this. I mean, you put 5 people in a room and ask them to give you a list of features you want to see on this board, and the whiteboard was full within 5 minutes, and then you have to start saying, okay guys, let's look at this practically. Which bits do we absolutely need as core functionality that fits the educational mission? Which bits can actually be as add-ons? Which bits are just going to cost too much so we can't have them either way? And let's just try and rationalise it down to what would be the final spec.
Because you mentioned in your talk about possibly chopping the Ethernet port, didn't you?
Oh yeah, well that was, yeah. Okay, well we all make mistakes. And I just said in the meeting, well, I tell you what will make it really easy. If we kill the Ethernet, then I'm going to save this great big clump of RJ45 and all the bits that go with it. I think I almost needed to hide under the table. There was a pleasant but verbal barrage of, you can't do that. We need it with Linux and the internet. We have a truly powerful product. And something that will actually be massively educational. Okay guys, I give in, it's staying. So Evan and myself, then spent another few weeks just honing down the price. What can we take off? I mean, one of the decisions we made is we did a very simple power structure for the USB. And that was because we thought, well, it's going to be a mouse and keyboard.
That's the polyfuses, wasn't it?
Yeah, the polyfuse, yeah. Polygate, as it probably should be known now. But, yeah, but we thought, it's going to be a keyboard and a mouse. So, why is that a problem? Hard disk drive, USBs, people wanting to connect webcams to it. But these were all things that we hadn't actually thought about. And what we realised then is that, our community, when that came out, is significantly more inventive than we'd given them credit for, which is foolish. I mean, we should have half realised that this was going to happen, but equally we should have half realised we were going to sell 5 million.
2020 hindsight.
Oh, yeah, I know. I love that stuff. It's perfect. But we didn't. But we made some mods fairly quickly on in the process to make sure that we could mitigate that. We actually replaced the polyfuses with resistors, and that helped. But the thing you always have to remember with Pi is we were designing to a price for 20,000 boards. So we haven't got that many options. And you can imagine the conversation with suppliers. Okay, so you want to build a little computer, and what are you calling it? You're calling it Raspberry Pi? For God's sake.
They must have thought you were nuts.
Yeah, I mean, sometimes we thought we were nuts, but we had this vision, we wanted to make it a reality. And just with perseverance and willpower, and also when we explained what we were trying to do, when we could actually get the guys to see the mission, if you like, they were absolutely on board. And Broadcom were immensely supportive, and all the other chip vendors have been immensely supportive of the mission, and have really tried to help us out where they could.
Because Broadcom won't normally supply chips in the 20,000 quantity, will they?
No way.
That was like an exceptional thing because of the charitable status of the foundation, wasn't it?
Because of the charitable status of the project, and a really excellent piece of internal selling by Evan, I'm sure.
Well, obviously him being in Broadcom helped a lot too.
I think it did, and we looked. I thought, okay, well, let's have a look around. And we looked at every micro we could find, and nothing was within a light year of what we got with the HDMI, the VPU power, all the peripheral set. It almost as if somebody had mystically designed that chip specially for Raspberry Pi. And they'd made modifications to that chip just to make it fit perfectly to be on Raspberry Pi. Who knows? But anyway, so we took that and we were in production, and a lot of people know that we had some early snags in getting that into manufacture. Because we were working from a zero ramp. We were nowhere. You know, we had a charity that had almost no money that needed support. And we found that support through Premier Farnell and RS, who very kindly got on board and put their immense logistical capabilities into manufacturing the unit. Without that, I think Raspberry Pi would have probably starved to death, because we'd had to make 20,000, sell 20,000, make 20,000, sell 20,000, then we might have got up to 40,000. We just couldn't have scaled the product.
And certainly not that quickly anyway.
Absolutely not that quickly. And of course the other thing that happened, as you know, we reshored it. So Eben phones me up, he's on the telephone to me, and he says, and he's just, you know, Eben can be a little bit, he says, I found this little company in South Wales that can build Raspberry Pi for roughly the same cost of what we're getting it over in Asia. And you know, of course, bit incredulous, and so I said, and he said, well, you just need to go down and have a chat with these guys. And I went, yeah, okay, I'm going to have a chat with them. What are they called? So I get the pen out and we're expecting you to sort of, and then he says, Sony. So, you know, right, okay, Joker, thanks very much.
Got you.
Got me, yeah, got me again. You know, but, and certainly now I went down, and their passion for the mission, their capabilities, their enthusiasm to get, you know, hunker down and get involved with it was tremendous. And so, as you know, we ended up moving production back to the UK, back to Pencoed.
That's a great feeling, isn't it?
It is, and we've never really looked back there. Just their passion for the detail, the quality. They just care about the products passionately. Everything they make, they care about. And especially the pie. I mean, they have school children around to show them the pie's being made.
And it's the failure rate's incredibly low, isn't it?
The failure rate is incredibly low because of their attention to detail and the relationship that they have with the design team. I mean, obviously, early days it was me, and I was juggling calls from Sony with my day job, but that's fine for a limited period of time. But then we said, look, how are we going to progress this project? Because now, I mean, now we're at the situation where we sold over 1 million. The price points all change, and we were heading towards 2 million. And so the actual metrics of a design change. I mean, whenever I get somebody through the door and say, I want to build a product, almost the first question is, well, how many do you want to make? Because that almost sets out the line you're going to go.
Absolutely.
You're not going to spend, I mean, it's like making plastic, isn't it? If you're going to make 2 of something, you'll probably make the plastic with an SLA or a 3D printer. If you want 20 million, the first thing you do is going to cut steel and you're going to press it, because the piece part price is a lot cheaper. But there's a big setup cost. Well, we couldn't afford a massive setup cost up front. But now we've got the volume, the semiconductor manufacturers were more interested in us, and the fact that it was called Raspberry Pi was a plus rather than a minus. And that, again, they were all on board trying to help us. We got lots of help off some of the major semis. I mean, some of them didn't make the cut to get it on the board, but that's just the way that the business works. But, you know, not for want of trying and not for want of being helpful. So at the same time, we said, okay, well, we've done the Sony migration, and at that time we said, well, what are we going to do now? Well, we really need a design team. I mean, as much as as I said, you don't want to let your baby go. You know, any board that you design, you sort of want to hold it close.
Absolutely.
But you're just going to suffocate it. And we were building a really competent team in Cambridge, with James Adams and heading up the the design. So I had lots of chats with him, and he was also he came in and he started working on the compute module, and you've seen that amazing piece of kit. And then so my team was sort of working on the B plus concept.
Right.
We knew what we wanted. We already had the list because they'd been red penned off the original list, so we knew what we wanted to add on. It was a question of could we do it
for the price.
For the price, always the price. And the answer is, with a lot of willpower, again talking to the manufacturers, we managed to get pretty much all the functionality we wanted on the B plus. And of course, we also had, as people will realise, we had one eye to Pi 2.
Yes. So you mentioned in the talk about the space around the chip.
Yeah.
It was a bit more than you perhaps would have needed without an eye towards that.
We sort of spaced things out a bit because we thought, well, there's an opportunity for a new chip, and that was on the way, but with the nature of chips, you don't know when they're going to arrive.
So this is something actually that came up in some blog comments on my blog about the Pi 2 when it came out. So people don't actually seem to realise the life cycle of a chip, because it takes at least a year or more than a year to actually get new silicon into production, doesn't it?
Well, it can do, and of course if there's a problem with it, it needs a metal change or it needs something to get it, well, it's a big qualification process to get a new chip on board. I mean, obviously Evan knows a hell of a lot more about that than I do, but from my experience, there was a fighting chance. It wouldn't fly first time. I have to say it'd be vanishingly small, but there's always a possibility, and it's all about risk management. So we didn't know for sure that we were going to get Pi 2 in the timescale, but that didn't mean we couldn't lay the groundwork. And the important thing is that it laid the groundwork both for Pi 2, for the hats, and for A plus, because everything was lined up so that we could cut down. I mean, we did agonise about the fact that we were going to change the footprint, and that meant a lot of cases were going to go into the not really usable on the B plus.
So all of this was laying foundation for the Pi 2 then, which.
Well, in a way, but it was also a major tidy up of the B. I mean, getting all the things that we wanted to do and all the I/O, because we wanted it all in a nice sort of synchronous position, such that there wasn't going to be another upset in the sort of fabric of Pi. And of course, a lot of work went into the fact that the Pi 2 is compatible. And again, has been mentioned everywhere, is that if you've got an original, Pi, you can still use the current distribution. It still works, and it works a lot faster than our very first one. So it was all about trying to not orphan off those Pis. We don't have the requirement to say, buy our next shiny new thing and throw away all the old shiny things that are now tarnished because we're stopping supporting them. That's not what it's about.
No.
But what I do say to people, people bought B pluses. Well, I run workshops on a B plus, and I show them a Pi 2 and show them how much faster it runs. But for those workshops, there's no advantage.
Absolutely.
In fact, a couple of games that some of the kids wrote go too quickly. You can't hit the buttons. In fact, we saw that, didn't we, yesterday? One of the kids had a Pi 2, and his game he couldn't get the scratch cap through the gate because it was moving too quick.
Fast.
Yeah. But on a standard.
Reminds me of, do you remember the 486 DX66 used to have a button on there, you could make it half the speed to 33 so that your games wouldn't run too fast.
Absolutely.
Yeah.
I mean, so I think the answer is, for a lot of things that we want to do, it's enough. Yeah. But what I've realised is that working with the kids in Manchester Raspberry Jam and seeing how they do it, that their sort of methodology is to have scratch on 2/3 of the screen, and then a web browse on the remaining third with whatever they're playing with and searching for assistance.
Yeah.
And if you talk to the guys who do Minecraft, that's exactly what they do.
Yeah.
I mean, my 12-year-old, he says, oh, I'm just trying to do this. Do you want any help with it? He said, no, I've found somebody who blogs on the internet who knows more about it than you do, Dad, so... No,
everybody knows more about it than Dad.
Of course.
I've got a 12-year-old.
Yeah, so gutted in Manchester. But the reality is that that's the way that they want to work.
Mm.
And so what the Pi 2 gives you is a much cleaner ability to do that. So it's got some significant benefits, and it really does now tick one of the final boxes on the original list that we need sufficient power to be able to browse.
Yes, certainly.
Effectively, without getting interminably tired waiting for it. It was quite funny actually yesterday. I don't know if you noticed there was 2 Pis, and he made a mistake, and the Pi was halfway through booting, and he had to reboot the Pi 2, and the Pi 2 got to the screen faster than the original Pi. So it does make a difference.
Yeah.
Yeah.
So I noticed on my comparison side-by-side video that the web browsing on the Pi 2 is actually, it's usefully fast. You know, it's really fast now compared with what the B Plus even was, and the boot time is just, you know, 15 seconds and you're there, that's brilliant. You know, that's better than most PCs actually.
Yeah, so it's going to have an educational outcome, and I think that's great. And I, like I say, I just cannot. Well, when we first created Pi, of course we were on a soft ramp. We had no other option. But it's been really interesting that with Pi 2 we've been able to organise a hard ramp with stock in the warehouse.
Yeah.
And it's just flown out.
So there was it 200 or 300,000 in stock on day one?
Yeah, and they'd gone in a few days.
Yeah, amazing.
And then there was already stuff in production to back that. I mean, I think Evan said it was what?
20,000 a day, wasn't it? Or?
Yeah, something of that order.
That's
impressive. We're really, people are munching through them because
Sony have put in a new line, haven't they?
Yes, they've got new equipment on the line to actually help with getting the stuff through. And of course, one thing they did, if you go back to the blog, is they now have an automated test.
Right.
They're trying to take as much of the labour-intensive parts out of it, so we can make more with not having to add that many more people.
So how many jobs have been created as a result of the Raspberry Pi project? It's more than 30, isn't it?
Oh, it's more than last time I looked it was 30, but it's gonna be way more than that now, I would have thought. And of course there's all the peripheral, it's probably created 2 jobs of the guy who makes the cardboard boxes.
Yeah.
Just for Pi. I mean, any positive manufacturing process in the UK creates jobs in other industry and other places.
I suppose. I mean, postal workers too, for the deliveries.
Well, yeah, anything, so it's always a good thing.
Excellent. So we haven't touched on physical computing. That's something that you're really keen on, isn't it?
Yeah, I mean that was my passion from day one. Is computers are fine, but when you actually start connecting them to the real world or measuring the real world, then it starts to get really exciting. So this is why I really like the little add-ons that give you even simple things like traffic lights. And what's interesting, as soon as you get a robot and it moves, you can actually outgun some of these games that are on the PC. The kids are more interested in this moving robot than they are in playing, some of these shoot-'em-up games on the PC.
I can control things.
I can control things. I'm under control, and I can write a program that makes you do something different.
Call me a big kid, but I still love the fact that I can press a button on my phone through the internet or local Wi-Fi. I can control a light coming on my Pi, or I can switch something on or off. I just think that's totally cool.
Yeah, but I think the important thing about it is that you've done it. You've done the thing that makes that happen. You haven't bought it.
Yes.
It's the fact that you've created it.
And you've learned how to do it, and it hasn't necessarily always worked the very first time.
And you've had to debug it, and that is a massively useful skill. I mean, somebody said to me, what's the point of learning how to debug programs? And well, it's quite simple. Once you understand the methodology of debugging, you can use it in everyday life to fix problems.
Absolutely.
Okay. I had the one the other week. Arthur was complaining that it was a cold, all the showers were cold. Well, how's that? So we turn on the hot tap, there's hot water. Turn on the cold tap, there's cold water. What's going on here? So you start thinking, so you cut it back, so it must be the control valve on the mixer, yeah, must be that, must be that. What it is the water board fixed a pipe leak, and now the differential pressure between the hot and the cold is so much, only cold comes out.
The old settings don't work anymore.
Exactly, yeah. Not what you think it is, but it was a process of elimination. And when you proved it wasn't X, you had to go and look for Y.
Yeah.
But,
so that's it. Yeah.
But it's the skill that you pick up as being an engineer, and is to say, okay, it doesn't work, what do we need to do to improve it?
So this is where Pi really scores highly, because you've got the kind of, well, let's call it the iPad generation, who are consumers of computers, but they don't really sort of understand how to make them do things they want. And that's really what the Raspberry Pi is set out to achieve.
Absolutely. It's the concept of being able to, I think, as I wrote somewhere, go create your dreams.
That's a good slogan.
And that's what it's about. And we've got to give the kids the tools to do that. That's our mission, to give them the tools to do that and do bigger and better things. And of course, there's lots of exciting things like AstroPi. I mean, that's really going to be an engagement piece to actually get it there out on and have your program running there on the
in space.
Cool.
Yeah.
And of course, that doesn't take anything away from Dave Ackerman's Pie in the Sky and some of those brilliant pictures. I think, as I said in my talk, that Arthur didn't actually believe the pictures he saw because, of course, the sky was black. And that can't be possibly true. And we had a long conversation after a quick look on Google to find out that I knew exactly what I was talking about. that the sky is does change the pattern of light and makes it blue because of the water in there and all this sort of good stuff. And so it's all fascinating. And I thought Dave's talk today was really, you don't realise how thin the atmosphere is in proportion to the size of the Earth, and you think, wow, that's all between us and
it's almost protecting us from the sun.
Exactly.
Wow.
So it's but it's this thing that I think all engineers think science is just awesome.
Yeah.
The more you dig into it, the more fascinating it becomes.
The more you realise you don't know, so the more you're spurred on to think about, well, okay, I don't need to know everything, but if I could just learn that little bit extra that I need to know now, then I'll learn the rest when I need it.
Yeah, did you see that one where the scientist was saying, he said, it would be the end of my world if we actually knew everything about everything.
Oh, absolutely. Yeah.
But he says the fortunate thing is that every time we find an answer to one thing, it generates at least another 10 questions.
Absolutely, yes.
So I think we've got a way to go yet. But I mean, I'm really excited. I mean, we're up to 5 million pies out there in the hands of users, creating all this awesome stuff. I've always been, in a sort of a local Manchester, gobsmacked by the things that people do with it, the inventiveness that they actually deploy.
That's the great strength, isn't it? Because the community has sort of got involved from day one, done things, blogged about it, really sharing their work,
shared what they've done,
sharing the improvements back to the community, and it's generated a whole new kind of thing, hasn't it? A new kind of ecosystem, if you like.
It has. I call it the Pi ecosystem, and it's created, and also, the contributing makers, whether those makers be individuals or whether those makers are actually businesses, to actually provide the tools, as I said, to make your dreams.
I like Piosphere. That's quite a good term. Piosphere.
Yeah, that's the other thing, of course, about Pi is we've really managed to get almost everything, and raspberry jams and
the puns are awesome.
The puns are awesome. Yeah. Punnet of puns.
Punnet of puns. Excellent. Well, Pete, it's been great having you on.
It's been a pleasure.
Real pleasure talking to you. Thank you very much. And it's been a fantastic weekend here at the Pi birthday party. If you ever get the chance to come, do so, because it's just fantastic. So many brilliant people to meet and talk to, and brilliant projects to see and talks and.
There's just too much to see and do. We're going to need to run it for a week next time to give us a chance to go around. We should have to repeat all the talk.
You said yesterday we need to hire the NEC and do
the whole thing,
a Maker Faire type thing.
That's it. The Pi Maker Faire, the whole thing.
We'd need a good Pi pun for that name, wouldn't we?
Yes, I think we would. I'll let you think about that.
All right, excellent. Well, thanks very much, Pete.
You're welcome.
This was Alex Eames and Pete Lomas for Raspberry.tv. Thank you for watching.